In our next example, we're going to find the Maclaurin series for the function f of x equals x squared e to the minus x. Again, we could set up our chart and compute derivatives and plug into the formula. In this case, it would be fairly difficult to compute the derivatives because of that x squared e to the minus x. We'd have to use the product rule. So it's much easier to say, okay, I know the series for e to the x is sum n equals 0 to infinity x to the n over n factorial. So if I want this series for e to the minus x, I just plug in a minus x everywhere there's an x, so I get sum n equals 0 to infinity minus x to the n. So we get minus x to the n over n factorial. Again, all we did here was we said, okay, everywhere there's an x, we need to be plugging in minus x, so we get minus x to the n. And then again, how does this simplify? So minus x means minus 1 times x. So this is sum n equals 0 to infinity minus 1 to the n x to the n over n factorial. So there's our series for e to the minus x. We wanted f of x equals x squared e to the minus x. So we're going to take this and multiply by x squared. So we get sum n equals 0 to infinity minus 1 to the n, x to the n over n factorial, all times x squared. Now that x squared, no n's in it, so we can pull that inside the sum. We get minus 1 to the n, x to the n times x squared over n factorial. And now finally these exponents add, so we get sum n equals 0 to infinity minus 1 to the n, x to the n plus 2 over n factorial. So we got our series for x squared e to the minus x by first finding the series for e to the minus x, plugging in minus x everywhere for x, and then we multiply by x squared.